Yeah.
so it's the okay. I thought it was like a screening for whether the podcast was going to happen or not.
No,
Okay.
no, it's happening right now, and you don't need to be
It's
prepared
happening
or
right
anything.
now.
So
Okay.
yeah, we'll be focusing on very casual stuff. Some of like every one of us, since we are child, we had this spacious dream. Every child you ask, especially in India, every child you ask, what do you want to be when you grow up? Uh, 5 out of 10 people say astronaut. So it's kind of an aspirational thing about anyone because when you're small, you look at space and you see all these shiny objects, you don't know what they are and all that. You see planes going by. It's very inspiring. So could you please give a short intro about yourself? Like how did you start into this field and what was your background about?
Sure. So I was actually one of those kids too. Um, I I saw astronauts walking on the moon,
Mhm.
and I said I would love to do that too. I want to be an astronaut. So I from very early age, knowing that, I tried to figure out how how to do that, how to get that. So I re read science fiction a lot. I studied
Mhm.
math and physics, but I also liking this podcast, in order to be an astronaut and to work in teams and things like
Right.
that, you have to be good communicator.
Mhm.
So
Right.
English and history, and I loved all those subjects. So yeah, I wanted to be an astronaut when I was a kid, and that drove me to study to become an aerospace engineer, and
Mhm.
eventually to work for NASA and do very cool things to explore our universe and our solar system.
And the thing is, you have explored so far that I couldn't even like thought about because all the like the major people know about they know about Earth, they know about the moon. Some people know about the Mars. I've never thought of Jupiter, Uranus, or Neptune, and you have that all in your portfolio. So
Yeah.
I have like full 5 pages about you with me, and
Okay.
yeah, I would like to ask some questions.
Cool.
Yeah. So, you are heading NASA's Jet Propulsion Laboratory, right? The JPL.
Yeah, I'm not the head of JPL. No,
Okay,
the director's Dr. Lori Leshin. Yeah,
okay,
she's a
got it.
wonderful
So,
person, by the
mhm.
way. Yeah.
And how
No,
long have you been with JPL?
I started when you mentioned Uranus. I started on the Voyager 2 about a year before the Voyager 2 flyby of Uranus, so
Okay,
1985. And
okay,
I was a young engineer, and I was on the flight team for the Voyager spacecraft. They were about to fly by Uranus and then Neptune. And for me, it was kind of mind blowing. I'm like, really? We're going to fly by this planet? I mean, that's what I dreamed about doing.
well, that is mind
So,
blowing. Yeah.
yeah.
And how long does it take to like to reach an object from Earth to Neptune or like to Uranus?
Yeah. So for Voyager 2, so it launched in 1977, and then
Mhm.
in 1986. So it was 9 years to get out to Uranus, and then 12 years to get out to Neptune in 1989, which sounds like a long time, but when you think about how far away these
Yeah,
like the planets is, it's not that long, right? I mean, the the planet Uranus is 20 times, roughly 20 times the distance from the Earth to the sun. When you look at the solar system, and just how far out is it?
okay. Yeah,
And so it takes a long time, and it takes, I would say, uh, I've learned to be patient, right? It's not
yeah,
like, oh, this is going to happen next hour.
yeah,
It's not like an instant thing. You have to, there's a patience to get out there. But then the pictures and the flood of discovery and stuff, it's like there's nothing like it. It's like really
right.
seeing things that humans have never seen before.
Humans have never seen, right?
Yeah, yeah, that's very exciting.
Very exciting. And Voyager 2. So it went out to both like Uranus and Neptune, right? And what is the speed of the rocket ship?
Well, when it takes off, it was going pretty fast, and then they used a technique. So there was a rare alignment of the planets that happens every 177 years. So every 177 years, you could send a mission like Voyager out because it did
Okay.
a what's called a
Mm-hmm.
gravity assist.
Yeah, yeah,
So you fly by a planet and you get some energy from
yeah,
it.
yeah, yeah,
And so the both the Voyagers flew by, so they got a lot of energy from the launch vehicle, and then they flew by Jupiter, got
yeah.
some more
Mm-hmm.
energy, flew by
Got
Saturn,
it.
got some more energy, and then
Uh,
flew by Uranus, got more energy, and got out to Neptune. But only one of them went that whole what they call the grand tour. So Jupiter,
okay,
Saturn, Uranus, Neptune. The what happened to the other one? Voyager 1 flew by Jupiter and Saturn, but targeted it at Saturn to fly by Titan,
okay,
the biggest moon in the solar system. Um, and Titan has an atmosphere, so they wanted to see they could see it from the Earth that it had an atmosphere. But what is this moon out that far away that has an atmosphere that's about as thick as the Earth's atmosphere, but it's different. It doesn't have all the oxygen in it
so Saturn's
out there.
moon has its own atmosphere. You're saying that?
Yeah, yeah, it has its own atmosphere. Titan.
Okay.
It again, another mind-blowing thing, right? It's
Yeah,
like, wow, what? Our solar
right.
system has so many interesting things in it. You can tell that's kind of what drives me too, is that, I'm always thinking, well, why is that? And what else could be there, right? It's like, there's always going to be something that's interesting that was never been discovered before. And then you go, well, why is that? So Voyager 1 flew by Titan, and when it did that, it
Right.
wasn't able to go to Uranus and Neptune also. So Voyager 2 went out to
Mm.
Uranus and Neptune. Yeah.
And please correct me if I'm wrong because I read this in my fifth grade or something that I haven't really like pursued like science as a subject for the studies. So we learned that the four planets, the first four planets after the sun are like solid planets, and after that like Jupiter, all these planets are gaseous planets, right?
Yeah. Yeah.
So
They're made of
they're
mostly hydrogen,
fully
some
made up of
helium. Yeah.
okay, and hydrogen is the lightest element we know of.
Yep.
So the mass would be like pretty low of these planets.
Well, yeah, except they're so big.
Yeah, yeah.
So
Right,
yeah, so they're big in physical size, but they're made up of things that are, like hydrogen, helium, that are lighter than
right,
what we usually see on Earth here. But and they're not rocky planets. Although at the
right.
core, so,
Mm-hmm,
so just to dive, the core of these other planets like Jupiter, Saturn, Uranus, Neptune, there probably is a rocky core that's right at the very center that's small, but then the rest of it's made of the gases, and
mm-hmm.
as the pressure gets greater it becomes liquid, and maybe even a thing called metallic hydrogen.
Metallic hydrogen.
Yeah,
Okay,
which
so
is
and it would be something to do with just with space. We don't have that on Earth. This metallic
no, but they're
hydrogen
I
thing.
think they've simulated in some labs on Earth. So if you take
Okay.
hydrogen,
Mm-hmm.
so another wild thing, right? If you take
Yeah.
hydrogen
Mm-hmm.
and you squeeze it with pressure, like
Mm-hmm.
millions of times
Mm-hmm.
what we have in our atmosphere here, it it becomes a substance called metallic hydrogen. And the reason that they call it metallic hydrogen is because it acts like a metal.
Mm-hmm.
Like in a metal, electrons move around. Well, if you squeeze it enough, it becomes this metallic hydrogen, and that's probably what's at the middle of Jupiter, because
So
it's
is it
so
like
big and the pressure gets so it squeezes so much at the center of it.
is it like something like I'm visualizing it like some liquid metal kind of thing? Is it like something
Yeah,
like
it's kind of
that?
like that.
Okay.
Yeah, but they haven't seen, they haven't made enough of it to see what it would look
Mm-hmm.
like there. But if you look up metallic hydrogen, you'll see
Mm-hmm.
these kind of liquid
Got
metal
it.
kind of
Mm-hmm.
things because it has metallic properties.
Okay. Got it. Got
Yeah,
it.
I told
And
you it's kind of wild.
yeah, it is wild. And like the Voyager 1, the Voyager 2, so we have sent them to Jupiter, Uranus, Mars, and all. Sorry, like Neptune. So, what was
Mhm.
the purpose behind all this? Because when I asked you about that, they are gaseous planets or not. So, can we do something with them? Because with Mars right now, we know that we can like kind of do something with that, like Elon is doing. So we can like maybe civilize that or like something and on those terms. But what can we do with like Jupiter or like Uranus or Neptune? Because these are gaseous planets. Now, I had a wild thought. I'm not an aerospace engineer like you, but I had just this wild thought that with some reactions or something, you can turn a gas into a solid. Can we do something similar with these planets? Like maybe a big bomb of something like a gaseous reaction or something, and we can turn these
Yeah,
things into solid.
I don't know about that, but let me circle back, you know, why did we go out there and what
Yeah,
do we want to
yeah.
do? So, I think, you know, as humans, one of the first things before we get to those points of, you know, saying, "Oh yeah, we're going to go to Mars" and things like that,
Mhm.
we've we've been you know, we're curious. We're like, "Well,
Right,
what's out there? What does it look like?" And that was true about Mars too, and still is true about Mars. And so one of the main things as humans, since we have rockets and spacecraft and things, we'd be like, well, what does it look like out there? And so we send a piece of ourselves, these robots, these
right.
spacecraft, we send them out to these places that we can't go to see what it's like there. Why is it? Why does it look blue? Why does it look um have the like if you look at Jupiter, you see the great red spot, right? And
Hmm,
if you
hmm.
look at a telescope, this telescope like even one you know that's small and you look at Jupiter, you can see the great red spot. You can see the big moons of Jupiter, the Galilean satellites, and it's like, well, what do they look like? And so we send these robots that are part of ourselves out there to see up close what does it look like and what's there and learn these amazing discoveries. And I think by itself, that's kind of what we do as humans, right? It's like we
Right.
want to find out what's out there.
Hmm.
So there are other things probably in the future we could do there too. I think only limited by our imaginations. You
Yeah.
know, like you said, well, I thought about, you know, maybe we could do this, and
Hmm.
you know, that's what sparks all the creativity and discovery. I think it's part of what we do as humans.
Right. So, actually, I'm very like curious about all this stuff about all the space stuff and everything. And later in my life, I obviously want to contribute something to it. I don't know how, because obviously I'm not an astrophysicist or something like that. But I want to contribute like in some way, shape, or form, something like that.
I think you're
Yeah.
contributing right now.
Yeah.
You're hosting this podcast. You know,
And
we're
letting
talking
people
about it,
know more about
letting people know
the
more
things they don't
about it
know.
because they'll
Yeah.
see this and they'll be like, wait a second, I didn't know that was
Right.
out there. What about this other thing? I think
Right.
that's a great contribution right there.
Yeah. So I had this question, and this is like a personal question also that uh, you've played a great key role in like shaping all the NASA's program regarding Mars. So how far do you think are we from like colonizing Mars and that stuff?
Well, from colonizing Mars.
Yeah,
So right now, for example, so I work in the Mars exploration program
yeah.
for NASA, which is the robotic program. So we have two rovers that are active on Mars. We have Curiosity and the Perseverance rovers,
And you
and
can see them
they're
live?
yeah, you can see the pictures. Well, it's not like live on Earth because they're so far away.
Yeah, yeah, yeah.
But every day they send back data and they'll send back pictures. And so if you go to the you know NASA.gov
Oh,
website, you'll see the
okay.
current pictures from there.
So I
No
was
question about it.
imagining something like that in your headquarters or like in your office. You must have this big screen on which you can see them live. Like
Oh yeah,
the things
it's
you're
not like
saying.
a live feed because
Okay.
they're so far away. I mean, light. traveling from there takes over 8 minutes to get to us,
Okay.
just even to Mars. So it's a long way.
Mm-hmm.
But you'll see the pictures from yesterday.
Mm-hmm.
They go up there right away.
Right.
And then we have numerous orbiters that
Mm-hmm.
are at Mars. We have five orbiters, and some other countries have other orbiters too. So I call it kind of the orbiter, but collectively, humanity has a lot of different robots that are functioning at Mars now. So I said this because I kind of wanted to, here's where we're currently at,
Yeah, yeah, yeah.
which is Mars is the most explored place
Mm-hmm.
besides Earth,
Mm-hmm.
in the solar system. I get. Moon's probably up there too, being explored. Now, our moon, the Earth's moon.
Yeah, yeah.
And so going to sending humans to Mars, um, and then colonizing, they're two other steps.
Mm-hmm.
And um, I actually don't know how long that's going to take. It kind of depends on, as humans, how much collectively do we want to do it? Right?
Right.
If we all say humans are really good at, if we put our minds to doing something
Yeah,
collectively,
we do
we'll do
that.
it.
Yeah,
And
we
and
achieve
so
that.
that's what it depends on. It's not so much, I mean, it's going to take technology and it's going to
Mm-hmm.
take other things too, but it depends on, well, how much collectively do humans want to do it? So if we want to do it a lot and everybody's, saying we should do this, it's probably comes certainly within our lifetimes. I would think that now colonizing, I'm talking about the humans sent there, to explore and then come
Right,
back. Colonizing, they would stay there, right?
right,
And so
right.
that would be the next step after that, to
Yeah,
learn how to live there and have many people there at once.
yeah,
But I think eventually we'll get there. Um, I don't. It's not tomorrow because
yeah.
space is hard, but it's because we can both imagine that now, right? As we're talking about it, you're
Right,
imagining,
right.
yeah, there's this future. And so I think
Mm-hmm.
I think it'll probably happen. Humans are really good at imagining things and then having them happen.
Yeah. But
But along the way, there's a
right.
lot of robots and exploration to do and discoveries to be made at Mars. There's still a lot of unexplored at Mars.
Do you think Elon will be the Adam of Mars?
I don't know. I don't know.
By the way,
You mean he
what do you think
himself
about
going,
Elon?
or
What do you think
you?
about Elon?
Yeah, I figured you'd probably ask me about that. I
Yeah.
love um, all the space companies that are the commercial space companies that have started up in the U.S. I know there's startups all around the world too, including some in India,
Yeah.
that are, and I think it's great. I love
Can you
when
name
they're.
some startups in India who are doing like this space thing?
um, Sorry, off the top of my head, probably not, but I
Do
try
you
to.
know there's this company called Tess Space? I don't know if you've heard about them or not. So they make like parts, parts and some things for the rovers, for the Mars rovers.
Oh,
And
interesting.
his
Yeah,
yeah,
that's cool.
so the guy's name is Edwin. He's from India, so he's from like the south side of India. And he's like pretty young. He's like 23 or something. And they have like some grant or funding from the government, and they're making this parts for the rover. So it's like quite fascinating to me.
It is fascinating to me too. I know
Yeah.
it's like because they seem similar, right? When you look at space rovers and spacecraft and stuff, they seem similar to kind of things we have on Earth that we would
Hmm.
use, but they have to be adapted to space. Space is a harsh kind of place. It's, there's
Yeah.
to get there, there's no atmosphere and there's yeah, so that's very interesting though. Yeah,
By
but
the
I
way,
I try to follow. Yeah.
it's very funny that you mentioned that that we have similar kind of things on Earth, but when you have to send something on Mars, I mean, it would look the same, but the functionality is all like different. The parts are different. I mean, you have to think about a lot of things when like something is sent to another planet, the speed it travels and everything. So
Yeah.
funny that I was reading the book about Elon Musk by Walter Isaacson, and in that something is mentioned that when they were building SpaceX, so they did quite a few experiments, you can say. So one incident I remember that they had to add some bolt or something to like bolt something together. And the bolt, which was certified for like the space things or the space objects, was costing like $300 or like $3,000, like something like that. And he just said to the engineers that just take a car bolt and fit it into that, and it worked like perfectly fine. It was like $3 or something. What do you think about those experiments? Like, should you go by the rule book, or should you experiment and like do your own stuff?
Oh, so this is probably not the actual use. I think both. So I mean, the way I think about it is you have to, and they all these companies do this very well, right? That it's like think about what the things you have to put
Right.
a lot of energy and effort into
Hmm.
because it must work, right? And
Yeah.
let's take the Bolt example. If it works fine in that environment in space, the same temperature, the same kind of stresses,
Hmm.
everything, but you have to think about it and say, okay, is it gonna get too cold?
Hmm.
Are there going to be stresses on that bolt that you wouldn't have on Earth here?
Yeah.
And if so, then you have to use something else that's going to withstand those forces. And you can usually uh, do some analysis pretty quick to find out if that's the case or not, because the
Yeah. Yeah.
engineers
Yeah.
and the software is really good these days, and they can do that analysis. And then sometimes you test it because you're not quite sure it's going to work, and then other
Hmm.
times you're like, okay, I can use this same part and we can send it in space and it'll be fine.
Yeah.
And but it takes some thought to it, and the companies are doing this. They're
Yeah.
thinking about how to do it, which is good. I mean, because space is a harsh environment, right? It
Right.
takes some thought. Can I circle back to Mars for a second again?
Yeah. Yeah. Sure.
You were
Sure.
talking about sending parts and things to Mars and stuff, and
Hmm.
Mars, it's kind of like Earth, but it's got 1% the atmosphere. So it's got some atmosphere there, but it's not like ours. It's mostly carbon dioxide. So
Hmm.
it's not like we can breathe it. And then it's also very dusty. So imagine like you've gone out into the desert or someplace that's super dusty or like a dust storm, and it's even dustier than that. So parts and things for rovers or when humans are going to go there, the
Hmm.
dust gets on everything. It coats the
I
you
was
see
about
the
to
if you
ask
look.
that. Like
Yeah,
I'm
sorry, I
imagining
jumped ahead, but
like the
yeah.
rover is there, and let's say I like some wind or like something. Is there like wind on Mars? Is it like
Oh, a lot of
windy?
wind. Yeah, it's a
A lot
very
of wind.
windy place.
Okay,
A lot of dust
so
storms and a
like
lot
the
of
wind
wind
goes by
and
and like a small rock or something, like it hits the camera or something of the rover. Can this happen, or like has it happened? Or like
yes. Oh yeah. You,
okay.
you can like if you look on the website, there's some of the rovers and landers have microphones and you
Hmm.
can hear it. You can hear the wind. It blows
Okay.
and it's dusty and it's so dry. It's take the driest place on Earth and it's drier than that
Hmm.
there. So this dust gets what they call electrostatic, right? It's like it'll stick to anything, just like if you
Right,
have
right, right.
styrofoam or something
I
like
see.
that, and
Yeah, yeah.
it sticks to you and you can't get rid of it.
Hmm.
And that's what happens. It just like sticks to solar arrays, it sticks to wheels, and so that's, we're talking about sending humans there and colonizing. Well,
Hmm.
that's one of the big things that needs to be figured out is how do you not get so dusty that you can't function anymore.
Yeah,
It's like,
maybe like Nike should make some clothes on
yeah,
that.
I don't know, anti-static. Yeah.
Yeah. Yeah, so let me ask you something again. Hmm. So I have like many things, sir. I'll need to choose them perfectly. Yeah. So What's the one thing about space that would blows people mind out, which like normal people wouldn't know, and you have got to know about it, and it will just blows people's mind out.
I think that's an easy question for me to answer. So if we if we found life outside of Earth,
Mhm.
because right now, everybody says, oh, there should be life outside of Earth. Probably, should be. Are we alone? Is the
Yeah.
life on Earth the only life that's in the universe? Do we have life in our solar system, other places, or do we not? We don't know. Despite, all the exploration that we've done, sending all the robots, and we have amazing telescopes.
Hmm.
We don't know. We don't know if there's life anywhere else. And imagine that we do find life in one of these places. I don't know
Hmm.
where it'll be, whether it's in Mars or
Yeah.
Enceladus, or you see the headlines of this planet, this exoplanet may be able to support life. If we find signs that there actually is life there,
Hmm.
can you imagine that? That is just, I
That
think
is
people
bizarre.
will.
I'm literally getting like goosebumps right now. And also, how do we measure that it's possible to have like life on some other planet? Because what I'm thinking is like we are a species, we are human beings, and we need oxygen. Maybe the other celestial bodies don't need oxygen. Maybe they survive on nitrogen or something, or maybe they don't breathe. I mean, it could
Right.
be anything, right? So, how could we like possibly say that this thing cannot sustain life or like something like that? How do we figure out that there's not life on that, or maybe there is possibility of life out there?
But that's an active area in research here on Earth, and there's many,
Okay.
many smart people that are trying to figure that out. And I'll say, well, I think for life to exist somewhere, you have to have an energy source, right? You have to have energy because life needs
Yeah.
energy.
Yeah.
And I say energy, for us, it's like food and oxygen and
Yeah.
things, but it could be something different so you got to
Right.
have the
Right. Right.
energy there. And then you probably need some type of water, um, in in a liquid form at some place. They're finding though that on Earth that there's, you've probably seen these. They're called like extremophiles and things like that. They live in very harsh places on Earth,
Yeah.
and
Yeah.
they're alive and they're in some of these conditions. So they study those, and so it's an active area. It's like, well, what would life look like outside of Earth? And because you have to kind of know
Yeah.
what it might look like. So
Yeah.
if
We're
you discover
curious.
it, do you know it's
Yeah.
life, right?
Hmm. Hmm.
It's like, yeah. So that's a very good question that many people are
Yeah.
trying to figure out the answer to is, well, what would life, could it look like outside of Earth? Does it look like what we look like?
Hmm.
Maybe not. Maybe it would look like something else.
Right. And can you count the number of people who asked you that our moon landing's fake?
Oh, can I count? I give talks to
Okay.
schools a lot, and other groups, and they ask me all the time,
So
Atlantic's
what is
fakes,
your answer
and
to
no,
that?
they are not fake. They
Okay.
are real. They
They're
are
real.
yes, they are real. The rockets,
Hmm.
the people who did it, they're, yep. Just like when we land robots on Mars or we go out to
Hmm.
Jupiter, all that's real.
Hmm.
That's one of the things I like about space exploration too. It's the real, when you're seeing the pictures coming from there, it's the real
Yeah.
deal.
Yeah.
Yeah.
And once like I think 2 or like 3, 4 years back, we had this picture of black hole all over the internet.
Oh yeah,
So
that was
yeah,
cool, wasn't it?
what
Yeah,
was
yeah.
that?
That
Yeah,
was,
that was very cool. And there was like inside of this picture that we are seeing, there could be anything. There could be emptiness. There could be like a whole another universe because right now there's these theories of simulation. I believe you must have came across those. So what do you say about that? So can we cover the black hole first, and after that we can talk about simulation? And are we living
Oh,
in
sure. Yeah,
are we
sure.
living in a simulation?
Oh, well, so these questions are getting good.
Yeah, yeah,
Pretty good. Uh, so let's talk about, the picture of a black hole,
yeah,
right? Because it's kind of like, well, how do you take a picture of a black hole? Because if you say light can't escape it,
yeah. Right.
then how do you get a picture? Well, so the picture of the black hole, what you see is the the matter, the physical things before they're going to fall into the black hole that give off energy because they're getting accelerated and they're moving around. And
Okay.
before that, they give off the energy. So that's what you're seeing it's not things that are inside the black hole. It's just outside the black hole. So think of something that has light coming off of it before it goes into the black hole. And that's what the picture of it is.
Yeah,
It's,
so it's
it's,
like there's a room which is pretty dark. There's a small
yeah,
window, and you cannot see anything which is inside the room, but there's like glowing objects because they're like fiery objects, like a fiery ball, like going inside that
about
room.
to go into it.
Yeah,
Yeah.
got it.
Yeah. And so that's what the pictures are of. And it is very cool seeing that picture of things that are right on the edge of that black hole about to fall into it. I
Yeah,
mean, isn't that's like when I was a kid and I told you I read science fiction and stuff, and
yeah,
that's like to me, I'm like, we're actually seeing a black hole now. I'm like, that was talked about
yeah,
back then, and now we're able to do that with these telescopes and techniques and things. That's pretty amazing.
yeah. I purposely do not read science fiction now or like any kind of fiction because I'm very fascinated with it. And I know all my time is going to be in that book or this series or that podcast. Yeah. So
Yeah,
I just
yeah.
purposely don't do that.
I still try to. I don't as often as I used to, but I like it
Mm,
because it it allows when you're reading it allows your mind to think of possibilities, right? It's like
yeah.
things that might be able to happen. So that's kind of cool to me.
And
Oh, so go back to this. Oh, sorry.
yeah,
Go ahead.
like just one question. Is your favorite movie Interstellar?
Which one? Interstellar?
Interstellar. Yeah.
I have a lot of favorite movies. It's a very good one. I
What do you think
like it.
about that?
Yeah.
I mean, how real is that?
They took great pains to make it pretty
Mm,
real. I mean, in all movies, they'll because you're watching something for a couple hours, you have to compress things in there
yeah.
and show it a certain way and stuff like that. But they were, I mean, I've met the people that were the advisors to that, like Kip Thorne and those people, and they're very respected, very and so they made parts of those movies very realistic and as much as possible that could be done. And I actually like speaking of movies or science fiction, when they make it realistic, that's the kind that I like to read. If it
Yeah.
seems like it couldn't happen or you're
Yeah.
bending physics too much,
Yeah.
I'm like, that's too much for me. But
Mhm.
it's okay. People can read it and stuff. But my wife teases me a lot. She's like, "Wait, you're pointing out the physics that couldn't," and I'm like, "Well, I can't help it."
Yeah, it happens.
Yeah.
So what would be a great movie to watch, like a science fiction movie? What do you recommend?
Caught me off guard here because there's so many good ones. I like Interstellar, like you said, I like
Yeah.
Interstellar. Um, I actually loved watching movies like The Martian. Uh, hmm, Sorry, I'm not thinking of a whole bunch of titles now. I'm sure after the podcast, they're going to flood into my head.
Yeah, no
But
worries. You can probably like email them to me or something.
yeah, you'd be
Yeah.
like, "Why did he send me a couple hundred things?" No, I'm just kidding.
Yeah, so we actually got off track. We were talking about that. We were talking about simulations. What do you think about that?
Oh, back so tying this thread back to when we were talking about, the
Yeah.
space environment and stuff, simulations and analysis are super important. And I mean, simulations are humans creating, software running on things. I guess there are some physical simulations too that are like analogs that they're important because they help us understand things and predict things.
What do you mean
I think,
when you say physical simulations?
well, like I think you're talking about simulations that are like software running on a
Yeah,
computer.
yeah, yeah.
There are other ways to simulate things too. You can, um, like for example, when we had this is just one example, but if you look at the planet Jupiter, I mean it's spinning one day on Jupiter's 10 hours, so it's spinning much faster than Earth, and
Hmm.
it's much bigger.
Yeah.
So when it's spinning around, think of like your tub drain, or you got water spinning in a pail.
Hmm.
That's a simulation of the planet Jupiter too, because it's spinning around so fast you can see the different things that happen with the fluids. So it's a physical simulation of the physical thing at Jupiter. So that's what I meant about they're not all software simulations. They can
Yeah,
be,
yeah.
some other thing that you set up that simulates something that you can't do. Like I can't bring Jupiter
Right.
into my house,
Hmm.
and simulate what it's like, but I can simulate it with a bucket with fluid flow going around in there. So imagine that's Jupiter spinning around, and that's a simulation.
Yeah. So I was actually watching a video by Neil Degerson,
Oh yeah,
and yeah,
I love
he's a
his
great
videos.
guy.
Yeah,
Yeah.
yeah,
And he was saying that, so someone asked him that, an interview or something, that what would you say if I asked you, are we into a simulation? And he said he doesn't have any good evidence to like support against that statement, because we could be a simulation. We could just be like this whole thing inside of an alien's computer, and like the whole thing is
yeah.
running
Okay.
on that computer, and he has created all these life forms. So I take example of GTA, Grand Theft Auto. So it's like this. I mean, if you see